Let me greet you, viewers, and take this opportunity to thank the people who have organized this session so that we can share the little knowledge that we have concerning industrial electronics and tool. Firstly, I would like to introduce myself. I am Mr. Malinga. I'm teaching at Orbit TVET College, Rustenburg campus. I'm into NATED program. Today, we are going to focus too much on DC theory. DC, as it stands for direct current. So our concentration is on direct current theory. Now, before we start with the direct current theory, I have a little bit of introduction that I would like us to share. Basically, it's a message in a form of encouragement. I took this quote that is from Barack Obama. It says, change will not come if we wait for some other person or if we wait for some other time. We are the ones we've been waiting for. We are the change that we seek. Now, please concentrate, students, industrial electronics N2 students, as we'll be dwelling much into the introduction to DC theory. The objectives of this lesson is to understand the definition or the explanation of DC theory in full. You also need to understand electrical quantities, relationship between the current, voltage, and resistance. In a nutshell, that will briefly explain Ohm's law. The current flow in a DC circuit, series and parallel circuits, Kirchhoff's laws. Remember, we have the Kirchhoff's current law and the voltage law. Lastly, it will be the series parallel circuit. That is the combination of series and the parallel. Now, I want us to master the concept before we can master the contents. Someone can ask you a question. Probably you are a student or you are a lecturer at a certain college or you are an engineer. What is DC theory? Now, what I'm going to outline here, it will give you a clear definition or a full detailed explanation of a DC theory. There are three essential parts of an electrical circuit. That is current, voltage, and the resistance. Those are the three essential parts of an electrical circuit. I want us to understand what is direct current theory. A theory is something that should be proven. It's something that you have to learn the other part of it so that you can practice or do the practical component thereof. Direct current is the type of current that does not change the direction. It only flows in one direction. It is direct current it's a type of current that does not changes the direction. Meaning it flows in one direction. It flows in one direction. Now, let us look at the three electrical quantities: resistance, voltage, and current. For us to come up with the three electrical quantities, we must have understood the structure of an atom. Remember that all materials, they are made up of atoms. And atoms, they have protons, neutrons, electrons. The protons are positively charged. Neutrons, they have no charge. Whilst electrons on the other side, they are negatively charged. Now that's why now we are going to come up with the direction of protons and electrons, because now when you look at this theory, you can see that we have protons that are positively charged, electrons that are negatively charged. So it simply means now there's a flow of what? Of electrons now in an electrical circuit, because we said we are going to concentrate on the electrical circuit. Now, the force of attraction between protons and electrons will make the electrons to flow from negative to positive terminal. That is the flow of electrons. And remember that when you have two unlike poles, there's a force of attraction. So that is why the electrons, they will flow from negative to positive. In other words, they are attracted to the positive terminal. Then we also have the flow of current, whereby it will flow from positive to negative. Now electrons, they flow from negative to positive, and the current in an electrical circuit, it will be flowing from positive to negative. Now there are terms which are being used to describe this flow of electrons. We have the so-called conventional current. Conventional current, of which we say it's a flow of current from the positive terminal to the negative terminal. And the electron flow from negative to positive terminal. Now, if you look at those two types of currents, they clearly illustrate direct current. You can see that it's either this type of current is flowing from positive to negative or negative to positive. There is no way it can be both positive to negative and negative to positive at the same time. That is why we say it's a direct current. Now, these electrons, they don't just flow, but there is a pressure which is pushing or causing the electrons to move from negative to positive. And that pressure, it is an electrical pressure. It is not just a pressure, but it is what? An electrical pressure. The term that we refer this to electrical pressure is voltage. So in other words, voltage is the pressure which causes the flow of current from the negative terminal to the positive terminal. I believe that we are getting there to the understanding of the direct current theory. Now, remember people that the flow of electrons, that's what we call electricity or electrical current. That is the flow of electrons. The other thing that we also need to understand, it is the sources of this direct current. We have cells, we have batteries, we have generators. I believe that from the previous level or the prior knowledge that you have, you understand that the combination of two or more cells is a battery. Combination of two or more cells is what? It's a battery. So these are the sources, or these are the few examples of sources for DC. Now, some people, they tend to confuse electromotive force and the potential difference. There is a difference between the two. Electromotive force, it is the voltage measured in an open circuit. Voltage measured in an open circuit. EMF. I'm just going to abbreviate it. Open circuit voltage. Remember, when you talk of an open circuit, that simply means now there is no flow of current in that circuit. And we have potential difference. Allow me to say PD. Let me just abbreviate it as PD. This is a closed circuit voltage. Closed circuit, it simply means there is a flow of current. And you also need to know the symbols of the voltage. You must remember, people, that we have the symbols for different quantities, for current, for resistance, for the voltage. So for the EMF and the PD, the symbol is the same, it's V, and the SI unit is volt. So now, I want us to to look at how the current will flow. Materials, they are not the same. They don't conduct electricity the same way. We've got the good conductors and we also have the bad conductors. Now, we have the so-called the resistor. The resistor is a component that resists the flow of current. That is the third part. At the beginning, we have talked about the three essential parts of an electrical circuit. So the last one, it is the resistor, the resistance. The resistance, it is the opposition to the flow of current. It is measured in ohms. And I believe that as N2 students, we know the symbols, different symbols of the resistors, the fixed resistors, the variable resistors, the adjustable resistors. We also know how to draw different types of resistors. Now, the resistance, in simple terms, it is a restriction to the flow of current. When the material is restricting the flow of current through itself, in other words, it cannot be 100% conductive. That's when we say there is what? A resistance. In other words, the current is being consumed. So, and if the current is being consumed, that simply means now the voltage will drop. The voltage drop now, it takes us back to the potential difference. Potential difference and the voltage drop, it's one and the same thing. As I said that, remember that a load, it will be consuming what? The current. So the voltage will drop. Because when there is a flow of current, it's a closed circuit. And there's no way you'll have what? The voltage drop or the potential difference if there is no flow of current. So basically, that's how we're supposed to outline the essential parts of an electrical circuit. Now, I said the resistor, of which it offers resistance or the restriction to the flow of current. They can be arranged in different ways. They can be arranged in a series manner, in a parallel manner, and the combination of the two. Now, when we talk of a series circuit, that's when the resistors are connected in series. Now, someone who does not know anything about electrical engineering now will not understand when we talk of series resistors. Now, let me briefly explain what do we mean when we say the resistors are connected in series. When resistors are connected in series, it simply means now one end of the resistor is connected to the other end. Allow me to draw the symbol of a resistor. This is the first resistor. The symbol is R. I will say it's R1. This is the end of the resistor. Now it's connected to what? To the other end. This is the other end of the resistor. So they are two. Let's say this one is R2. The two resistors, they are connected in series. That is a series connection. Now, we need to understand how do we come up with an equivalent resistance or the so-called total resistance when the resistors are connected in series. Basically, the sum of the resistors which are connected in series, it will be equal to the total resistance. So if you have two resistors, or let me add the third one, so that there are three, the total resistance, it will be R1 plus R2 plus R3. That's when the resistors are connected in series. Now, the other thing which is very important, students and viewers at home, you need to understand that the current in a series circuit is the same. It doesn't change. the current in a series circuit is the same, but the voltage is not the same. There's a voltage drop. There is a voltage drop. Now, this voltage drop, the voltage will drop across R1. It will also drop across R2. It will also drop across R3. Now, this voltage, it will drop based on the amount of resistance per resistor there. In other words, now, we also need to consider one of important laws. Ohm's law is the one which says when the resistance is high, the current will be low and the voltage will also be low. Now, what we are going to do here, we will say V1 plus V2 plus V3 is equals to what? Vt. In other words, if the total voltage for this circuit, if the total voltage is 10 volts, the sum of the three voltage drops should be equals to 10 volts. There is no way it will be above 10 or less than 10. Now, that principle or that law is referred to as what? The Kirchhoff's voltage law. Remember, I've mentioned Kirchhoff's voltage law at the beginning. So the Kirchhoff's voltage law, it states like this. The sum of voltage drops in a closed circuit is equal to the total applied voltage. Don't forget, closed circuit. That simply means now there's a flow of what? Of current. I believe that we now understand the series circuit. Now let's move on to the parallel circuit. The resistors, when they are connected in parallel, it simply means now when you calculate the total resistance, we use this formula 1 over RT. It's 1 over R1 plus 1 over R2 plus 1 over R3. Now, the voltage is the same for a parallel circuit. These resistors, they are connected in parallel. R1, R2, R3. This is the positive terminal. This is the negative terminal. Voltage is the same, but the current is not the same. These resistors, they will divide the current. So the parallel resistors, we call them the current dividers. We call this the current dividers, the three of them. Voltage is the same. And the value of the total resistance for the parallel circuit is less than the smallest resistor, or the value of the smallest resistor. Unlike in a series circuit, whereby the value of the total resistance is greater than the value of the biggest resistor. So basically that is the parallel circuit. And then now there's a law that we use to come up with the total current. Because the total current here, it will be I1 plus I2 plus I3. Let's say the current across R1 is I1, across R2 is I2, and across R3 is I3. So when we have the sum of currents which is equal to the total current, we have applied the so-called Kirchhoff's current law, which states like this: the algebraic sum of currents entering a point is equal to the algebraic sum of currents leaving the point. And now lastly, we have the combination of two arrangements or two circuits, series and the parallel circuit. Now, when we have combined the two types of circuits, it simply means now we have to consider both principles from the series and what? And the parallel. So hence we say it's a series parallel. It is the combination. Now, circuit diagram question 1, I believe is clear. There's a couple of resistors, there's the total voltage, and there's questions below the circuit diagram. The first question, it says, calculate the total resistance of the circuit. Now, before you calculate the total resistance, you need to analyze the circuit. In other words, you look at the parallel resistors. After you have considered the parallel resistors, you concentrate on the series resistors. That one, it will give you the total resistance of the circuit. Now, if you look at this circuit, there's R1, there's R2, there's R3, there's R4, there's R5, there's R6. Now, to save time, I'm not going to draw it. I just want to go straight to the workout of this circuit so that we can get the total resistance of the circuit. Now, as I've said, it is advisable to start with the parallel so that we have a series resistors whereby you'll get the total resistance, or you just have to add them. The first part, remember the current flows from positive to negative. The current will split, and the first current, it will flow through R1 and R2. The other one, it will flow through R3, and it will split again to flow across the 3 resistors. So when it splits, that's when we say now, or when it divides, we say we have a parallel circuit. Now, can we agree that R4, R5, R6 can be reduced to a 1 resistor? So in other words, I will say 1 over Rp. That is the first section of parallel resistors. That is 1 over R4 plus 1 over R5 plus 1 over R6. The value of R4 according to this diagram is 4. The value of R5 to this diagram is 5. The value of R6 according to this diagram is 20. You punch your calculator so that you can get the answer. So it's 20. So you are going to have 5 plus 4 plus 1, of which is 10 over 20. But remember, we are not looking for 1 over Rp1, we are looking for Rp1. So then you do the inverse, or you reciprocate, whereby you'll be having 20 over 10, of which is equals to what? 2 ohm. So in other words, the combination of the 3 resistors is what? Is 3 ohm. So that 3 ohm, I'm just going to make a rough sketch here. That is R3. It's R3. It's connected in series with Rp1. Rp1 is 2 ohm. R3, it is 18 ohm. So the 2 resistors, they are now connected in series. So when you calculate the total resistance for this circuit, we'll say R3 plus Rp1, of which is 18 plus 2. That gives you what? 20 ohm. We'll continue with the rest of the questions. But for now, I believe that we understand now the principles of series circuit, the parallel, and the combination of the 2, which led us to the so-called direct current.